Okay, so we are done with the reactions of beams. Now this lecture will be all about the reactions of frames. So for the reaction of plane structures, specifically frames, the procedure of analysis is the same with your statically, the same with your beams. So kung papansin nyo, similar lang yung procedure of analysis. Again, draw the free body diagram and then determine if the structure is statically determinate or indeterminate. Again, if indeterminate, and the analysis. Then use the equations of equilibrium to try and solve the problem. Okay, so we have this example. Okay, so here determine the horizontal and vertical components of the reactions at points at the pins A, B, and C of the two-member frame shown. So, based pa lang sa problem, alam natin na two-member siya. Then again, ulitin ko, pin is another term for hinge. No? So, we have an internal hinge at B. Kasi kung mapapansin nyo na, we have 1, 2 reactions. 1, 2 reactions. So, we have an additional equation. So, this is statically determinate. Okay, now, to try and solve this, like what we did on the beams with internal hinge, ibig sabihin kapag may internal hinge tayo, we can separate the two members. So, kasi hindi natin siya pwedeng i-solve as a whole, pwede natin siyang ihiwalay. So, separating the two members, magkakaroon to ng internal by, tapos may bx siya because we have a horizontal force. Ayan. Itong 8, magkakaroon niya ng vertical component. Sorry, 8 times 4/5. Tapos, ito naman, 8 times 3/5. Okay, so magkakaroon ng horizontal component. Thus, we will have an internal axial force dun sa loob. Dito. Or in line with the direction of BC. So, check natin yung free body diagram. Okay, so ito, you'll notice we have separated the two members. Now again, you can only separate the two if you have an internal hinge. Or, dalawang separate members talaga sila na pinagtugtong lang by a pin support. So, etong direction, assumption lang to, we have by upward, bx papasok, action, reaction, so going to the left naman, then downward. Now, for us to solve this, yung 3 kN meter times 2 ginawa ng concentrated load, kaya naging 6. So, pinakamaganda, unahin natin sa segment BC. Diba? If you do summation of moment at B, makakancel to, you will get the value of your CY. CX is also passing through, diba? Dire-diretso yan dapat. Dadaan siya sa point B. So, cancel yung CX. If you do summation of moment at B equal to 0, you will get your CY. You have positive clockwise. 6 times 1 minus CY times 2. This will give us CY is equal to 3. Or, just by inspection, kung mapapansin nyo, this is symmetrical. So, obviously, yung 6, it will be equally distributed to BY and CY. So, pwede nyo na lang ilagay 3, 3. So, the answer is 3. And then, for the value of CX and BX, you cannot still compute them using segment BC because kulang ang equation. So, yung BY na 3, transfer na natin yun dito. Then, we can use segment AB para makompute yung value ng BX, AX, and AY. So, tignan natin. Yan, number BC. Nakuha na natin yung BY. Makukuha din natin yung CY. Or, again, you may not write this one, pwede nyo ilagay by inspection. Since this segment is symmetrical, ibig sabihin pantay, no? Symmetrical. Pag equally divided yung 6 sa BY and CY, so BY, 3 kilonewton. So, it's up to you. You may write this down or this. Let's go to the next. So, 3 yung sagot. Check natin. Lagay ko na yung values. This is 3. This is 3. 3 and 3. Now, to get the value of AY, pwede tayong mag-summation of forces vertical. But if you notice, this is an inclined or an inclined force. So, kunin muna natin yung vertical force. Diba, ang vertical force niya, component is 8 times 4 over 5. Horizontal component is 8 times 3 over 5. Now, if we do summation of moment, first hanapin muna natin yung AY. To do that, pwede kayo mag-summation of forces vertical equal to 0, positive upward. Example, AY upward siya. So, plus AY. Ito yung isa pang vertical load, pababa, so minus 8. Is 4 over 5. Next is yung BY natin, which is pababa rin. Minus 3. Meron pa bang vertical? Wala na. So, kukuha natin yung AY. Okay, compute. And then, para makuha natin yung BX, pwede tayong mag-summation of moment sa A. Makakancel tong dalawa. Diba? Tapos makukuha natin yung BX. Try natin. Summation moment A equal to 0, positive clockwise. We have 8. Ulitin ko, perpendicular distance. So, yung 8, pwedeng siya na yung gamitin nyo. Perpendicular siya. So, the perpendicular distance dun sa point A, which is 2 meters. So, we have 8 times 2, clockwise direction. Then, yung BY din, ito yung perpendicular distance, di ba? Which is 2 meters. So, plus BY, which is equal to 3. So, 3 times 2. Then, yung BX naman, ito yung perpendicular distance niya. 1.5. Diba? Ito yung perpendicular distance. BX to A. So, we have that is counterclockwise minus BX times 1.5. This will give you the value of your BX. Check natin. Now, after you have your BX, pwede na lang kayong mag-summation of forces horizontal. Makukompute mo din yung AX. Tignan natin. Number AB, yun, summation of moment A. Ulitin ko perpendicular distance niya papunta sa A. Distance nung BY. Itong line na to kung nahihirapan kayo, draw kayo ng line. Tapos distance. Ito naman BX, draw kayo ng line hanggang sa point A. Tapos yung distance. Ganon. Perpendicular distance. So, next. Summation of forces X. So, we have ito na yun. 3, 5 times 8. Yung horizontal component. Tapos, minus 14.7 because going to the left. In-assume natin na positive going to the right. So, therefore, ang sagot is positive. Therefore, your AX is also going to the right. Summation of forces Y naman, yung kanina na sabi ko, add lang natin yung vertical component plus yung BY na 3. Ayun. This will give you your AY, which is upward. Now, lastly, what is the value of CX? Kung mapapansin nyo, we have your BX. Lagay nyo na lang dito. BX is equal to 14.7. Obviously, yung BX i-resist siya ng Cx. So, therefore, your Cx is equal to 14.7. Then, you may just write this down by inspection. Or, you may do summation of forces x equal to 0. Nalagay natin, assuming positive going to the right, we have 14.7 minus Cx, di ba? Cx is equal to 14.7. So, that's it for the frame. Example number 1. Now, example number 2. Yeah. And determine the horizontal and vertical components of the reaction A, C, and D. Then assume the frame is pin connected at A, C, and D. So, ulitin natin. This is pin support. Pin yan. So, may internal hinge daw ulit tayo sa C kasi pin din siya. Internal hinge din ulit. And then, pin connected ulit. So, again, ulitin ko, kapag may internal hinge, ibig sabihin, we have two separate members. We have member A, C. Isang member lang siya. Isang member lang to. So, kung dodraw ko siya, tapos, meron tayong EY. Tapos, AX. Internal forces to, na. So, we also have CY. Tapos, CX. Then, kung yung kabila naman, isang haba lang. Tapos, para sa internal forces, we have DY, DX, CX, tapos CY. So, ganito yun. Mangyayaring itsura niya kapag gawin natin. Then, if we write down the forces, copy nyo na lang yung 50, 40. So, ganun. 50, 40. Tapos, yung uniform load natin dito. That is, ilan yan? That is 15. So, ganun lang. I-separate natin sa 2. Na ano yung pinakamadaling masolve? Pwede natin tingnan yung segment CD. Diba? This is 6 meters. Obviously, ulit, this is symmetrical. So, therefore, yung uniform load natin, it will be equally divided sa reaction ng CX tsaka DX. So, you may just do 15 times 6. Magiging siyang concentrated load na siyang 90, di ba? Now, again, it will be equally divided sa CX and DX kasi symmetrical. Therefore, ang CX is equal to DX. Equal siya sa 45 kilonewton. Now, for the value of DX, CX, DX. Now, for the value of DY and CY, we can't compute it yet. So, punta naman tayo sa segment. AC. Para sa segment AC naman, best way to solve, mag-summation of moment tayo dito sa A. Diba? Pag nag-moment tayo dito, makukuha natin ang we will have two equations, two unknowns. Kasi pag nag-moment tayo dito, we have two unknowns, CY and CX. So, pwedeng ganun yung mangyari. Mag-moment tayo sa A. Summation moment A equal to 0. Ang mangyayari, we have 50 times 1.5. Tapos, 40 times 3.5. Tapos, ang CX natin, anong distance ang CX sa A? That is, ito yung distance niya, no? 4 meters. So, plus CX times 4. Yung CY naman, ang distance niya sa is, ilan yan? 1.5 plus 2, so 3.5 meters naman yung distance. So, plus, minus. That is counterclockwise. Counterclockwise, minus CY times 3.5 equal to 0. This will give you your CX and CY. Value of CX and CY. Tapos paki-compute na lang. No? So, you will have your equation number 1. Now, since your CX is also computed na yung CX natin pala, sorry. CX natin is computed na, sorry, nakaforgot. CX is equal to 45. No? So, lagay na lang din natin dito. CX is 45. Makukompute na pala natin yung CY. Now, what happens if okay na din yung CY? Check natin. Now, pag nag-summation of forces horizontal tayo, obviously, ang ika-counter or ang restrict ng AX is CX. So, this also will be 45. Ang kulang na lang dito is AY. So, ang gagawin na lang, ang CY natin is na-compute na. So, summation of forces vertical na lang, 50 plus 40 minus CY, equal na siya sa AY. So, check natin. Ayun na. Number CD, ito yung sagot. Ito yung CX, tama, 45. DX, 45. Tapos, mag-moment tayo. Makuha natin yung CY, AX, AY. Okay, so, from here, try to solve na lang, no? Using the FBD that I have drawn. So, ito yung values. Ulitin ko na, kapag may internal hinge, you are allowed to separate the two members. If there's an internal hinge. For example, itong ABBC, fixed support to or rigidly connected, ibig sabihin, you cannot just cut it at that portion para kumuha kayo ng equation. You will treat this member, ABC, as a whole. Okay, so one more example. Determine the reactions at the supports AB. The joints C and D are fixed connected. Ibig sabihin, fixed connected yung C and D. So, we will treat ACDB as a whole, no? Hindi tayo pwedeng mag-cut ng segment. Now, we have a hinge support. So, this will be, meron tayong AY, then meron tayong AX. Now, we have a rocker support. Now, a rocker support is the same with your roller. So, may isa lang yun na force, RB. But since this is inclined, ito yung angle niya, no? Kapag mag-draw tayo ng straight line, this will be the triangle. We have 3, 4, and 5. Ganyan. So, kung kukunin natin yung horizontal and vertical component ng RB, magkakaroon tayo ng RBY, which is equal to RB times, ilan yan? 4/5. Ang horizontal component niya naman, RBX equal to RB times 3/5. Tingnan natin, anong pinakamadali? We may do summation of moments at A. Pwede mag-moment kayo sa A, no? If you do summation of moment at A, it will eliminate AX and AY. Ang kuha nyo lang is RBY and RBX in terms of RB. So, masasolve natin siya. Isay natin, summation of moment A equal to 0. Positive clockwise. So, we have the 10. Convert nyo into a concentrated load. This is 10 times 3, so 30. Moment arm is 1.5. No? So, we have 30. Plus, unahin natin yung horizontal. Ulitin ko yung drawing, masyadong magulo na. Ito natin yung color. So, dito yung RB times 4 over 5. Ito yung RB times 3 over 5. So, ito yung RB lang. Ang triangle natin is 3, 4, 5. So, doing the equation, ulitin ko, summation moment A equal to 0, positive clockwise. This will eliminate the reactions at A. So, 10 times 3 para maging concentrated load times the moment arm, 1.5. RB, X is counterclockwise, so minus RB, RB times 3 over 5. Ang moment arm niya is 2 minus 4. So, itong distance na to, this is equal to 2 meters times 2. Yung RB times 4 over 5 is counterclockwise din. So, minus RB times 4 over 5. Ang distance niya is ito, which is 3 times 1.5. This will give us the value of your RB. Now, please take note, this is the RBX. Ito naman yung RBY. Times the distance. So, makuha natin yung RB. Now, by doing summation of forces vertical and horizontal, kapag meron na tayong RB, we can now get the value of your AY. If you already have your RB, may check na to. Pag nag-summation of forces vertical tayo, makukuha nyo na din yung AY. Similarly, since ang only horizontal force present is ito, so RB multiplying it by 3 over 5 obviously will be the value of your AX. So, check na din siya. So, check natin. Ayun na. So, the force at B or RB, ayan yung sagot. Tapos, ang AY natin, summation of forces vertical lang. Tapos, summation of forces horizontal for AX. Okay, so that will be all for the computation of frames. So, again, we are only using 3 equations. Again, always remember, if fixed connected or rigidly connected, hindi nyo po siya pwedeng paghiwalayin. You will treat it as a whole. But if there is a pin connection in between members or there is an internal hinge, you can separate the member for an easier solving of the problem. Mas madali yung pag-solve, yung paghinahati. But most of the time, it happens kapag more than 3 yung reactions. Kaya nagkakaroon tayo ng internal hinge or pin connection. In this example kasi, we only have 3 equations, tapos 3 unknowns. So, ano siya? One member lang siya. Or rigidly connected yung each end. Okay, so again, if you have questions, just message me in Messenger. So, thank you.